Welcome to the first lesson of the quantitative chemistry topic. In this topic, the key questions are: 1. What is conservation of mass, and how is it applied in chemical equations? 2. What is relative formula mass? Key terms that you need to be familiar with: conservation of mass, balanced chemical equations, relative formula mass. In today's lesson, we will talk about the conservation of mass and balancing chemical equations. Also, we will define relative formula mass. In chemistry, the law of conversion of mass is an essential principle. It states that in a chemical reaction, no atoms can be lost or created. As a consequence, the total mass of the products is equal to the total mass of the reactants. As a further consequence, chemical equations can be balanced if they are written by symbol equations. Let's start with the term relative atomic mass. We know that atoms, and particles in general, have masses. These masses are very small compared to the mass of a macroscopic object. Therefore, it is now convenient to use 1.6 multiplied by 10 to the power minus 27 kilograms as the mass of a hydrogen atom. This would make calculations overcomplicated. Therefore, in chemistry, we try to use other mass units. For example, atomic mass units, AMU. AMU is defined as the 1/12 of the mass of one carbon-12 isotope. AMU is used in defining the masses of every atom. Relative atomic mass is a dimensionless mass of any atom, and it is the mass of the atom relative to the atomic mass unit. Task. Now please pause the video and use the periodic table below to work out the relative atomic masses of the following elements: He, Na, Ca, Fe. Hint: remember the definition of relative atomic mass. Extension: how would you take different isotopes into account? Now let's discuss your answers. The periodic table contains the average masses of each atom. The word average is important as atoms have isotopes that have different masses due to the different number of neutrons. These average masses are the relative atomic masses, as follows. The following diagram shows how to consider the different isotopes in the example of chlorine. You need to consider the abundances and multiple relative masses of each isotope when the average is calculated. Based on this idea, a further term called relative molecular or formula mass, MR, can be introduced. Relative molecular mass is used for molecules, entities that contain more than one atom. It can be calculated as the sum of the relative atomic masses of all the atoms involved in the molecule. For example, the relative molecular mass of H2 molecule is 2 multiplied by ARH equals 2.0, while the relative molecular mass of H2O molecule is 2 multiplied by ARH plus 1 multiplied by ARO, which equals 2.0 plus 16.0, which equals 18.0. Task. Now please pause the video and use the periodic table above to work out the relative molecular masses of the following molecules: H2O2, CaCO3, H2SO4. Hint: remember the definition of relative atomic mass and relative molecular mass. Now let's check if you have it right. Here are the solutions.